This week we're studying the difference between physical and chemical changes, along with what happens when we combine materials in science. Physical changes, they are things like ripping, tearing, cracking, grinding, mixing, sanding, splitting, polishing. Chemical changes, you notice my little chemical bubbly going on up here. You'll see signs like bubbling. You'll have color change. Let me preface that with, you'll have color change that isn't induced by stirring, like Kool-Aid. I know Kool-Aid the water changes color when you mix Kool-Aid, but that's because of a dye. That's not because of the compounds reacting with each other. You might have temperature change. When you mix two things together, it'll get hot. It might get a little colder. You might see foaming and you'll see fuming or steams or vapors coming off. These are signs of chemical changing. Physical changing, it requires some kind of outside influence. Mountains are broken down because gravity's pulling on the rocks, and as cracks form in them, it pulls them, and then the mashing and the avalanche bouldering, breaking each other into each other. Physical changes, like when you make things like Kool-Aid, require some kind of stirring rod. You have to mix it up, make a solution with it, make together a mixture of raisins and nuts to make trail mix with a little bit of shaking in a bag. Requires a knife or grinding tool. Some kind of outside force is acting on it to physically change it. For example, kind of like this index card from a hole punch. I'm physically changing this by punching holes in it. This now is different than it was before. As a matter of fact, now you have these little parts that I'm dumping into the floor that are different than it was before. It's been physically changed. But here's the big thing about physically changing something. If it undergoes a physical change, the new stuff you got still has the same composition as the original parent material. All them punched hole dots that I just dropped in the floor, they're still paper. If you were to have a chemical formula for them, they would still have the same exact chemical formula as this. They're just smaller. Sand, even though it's tiny and granular, is no different than the quartz that it was originally chipped away from, the quartz rock that it was chipped away from. It's still the same exact substance, only smaller. Kind of like when you take your pencil and then sharpen it in a pencil sharpener. All the pencil shavings, they're still wood, they're still lead, they're still pencil, they're just smaller in a different form. Now with chemical changing, it occurs naturally when compounds come in contact with each other. And it changes the substance at the molecular level. It makes a new substance. This and that isn't a new substance. When I take Kool-Aid powder and Kool-Aid, that's not a new substance. But if I take baking soda and vinegar, I get a new substance. It's that gas. It's what causes that foaming action that you see that you guys love. One of the biggest examples of chemical change that you guys will experience is rusting. You leave your bike out in the rain, it rusts. You got rusts on cars. You got rusts on any kind of metal. Well, what happens with rust is that the iron comes in contact with water, and the water and the air and the iron actually turn the iron at the surface without any input by us into an iron oxide, and it's no longer iron. It's now, instead of having just being iron, Fe, it is now FeO2. It's a new substance, a weaker substance that's more brittle than real metal, which is why it crumbles and falls apart. The big difference is physical changes, same material that you started with, just in a new form. Chemical changes change the object at its molecule level and makes a new substance. We're going to do some labs this week. We're going to talk about mixtures and solutions, and we're going to keep coming back to this idea about what's the difference between physical and chemical change. Have fun.